Yeah, all right.
Let's do a couple examples here.
D is 5.
Alright guys, look at example 1. What are we solving for?
D.
Solving for density. So density is mass over
5.
volume.
5.
So we get 55 grams.
Oh wait, this is a math, we can't do that.
Divided by 11.
Spencer.
What?
Oh, it's not 5.
It would be if this is math.
Oh,
So we, guys, if you don't mind. So we take 55 grams and divide by 11 milliliters.
What do we get?
And therefore we get density of
5 grams per milliliter.
5 grams per milliliter. And that's your final answer. And I want you guys to do the next 4. Or sorry, the next 3.
Tanner.
Here for number 2. Well, we're going to take our mass and divide it by our volume, right? That's 45 milligrams. Divided by 10 milliliters. What we're going to do then, take 45, divided by 10. We get 1.5. And then what would our units be? Milligrams, 4.5 milligrams per milliliter. Tanner, what'd you get for example 3?
I got 11 grams per milliliter.
0.11 grams per milliliter. All right. Corey, what'd you get for number 4?
5 grams per milliliter.
5 grams?
5 milliliter.
5 milligrams per. Okay. Now this is gonna be tough. Which of these floats?
Example 3.
Example 3.
Example 3?
Yeah.
Okay, I agree. Example 3, yep, that works. Is that the only one?
Maybe.
Example 2.
How do we know if it floats? What's the density of water? All right, in order to float, that means that it would have to be less dense than the water, right? So, what's the density of water?
1 gram.
1 what? 1 gram per milliliter. So the density of H2O has to be 1 gram per milliliter. Guys, this is a fact you are expected to know for this class.
I'm going to learn it. I know it.
The density of water is 1 gram per milliliter. So, yes, number 3 is definitely less than 1 gram per milliliter. But take a look at number 2. Is 4.5 milligrams,
Yeah, it is less.
is that less than 1 gram?
Yes.
Yes, it is. So that also floats.
Doesn't make
Is
sense.
5 milligrams less than 1 gram? So that would also float. What about 5 grams per milliliter?
No.
Nope, doesn't float. What if I was 1.2 grams per milliliter? Would I float? Would I sink to the bottom?
No,
Why not?
because you don't have enough density of this one.
Yeah, and by density, there's not enough discrepancy between the two values. 1.0 and 1.2 are fairly close to one another. So you're not really going to get a complete mix, complete separation due to their densities. So it's really kind of important when we make that connection, that their densities are somewhat close. Again, though, this is talking about liquids or fluids or gases, they'll pretty much mix pretty easily and kind of sit around one another. To solids, think about that one for a minute. Will solids separate themselves with density? Why not? Why would they?
Because they have like chemicals.
It's not, they're locked into this lattice work. Okay, and think of it, what's the biggest difference between a solid and a liquid? Yeah, it's hard, okay? But it's a way that the atoms of the molecules arrange themselves. In a liquid, the atoms or molecules are allowed to kind of separate and they kind of disperse. But in a solid, they're packed in there nicely and organized in a very tight lattice type of configuration. It's very difficult to break through that lattice work. So when you have solids, they're not really going to sort themselves out through density. Okay, they're not going to give way. Because basically what you're really doing with density is you're literally pushing through molecules and pushing other molecules away. All right.
Next,
What do you think's on the next page?
something
Something else?
else.